development sponsored by the Ryan Aeronautical Company, the United States Air Force, in February 1962, contracted for the manufacture and flight testing of a special drone reconnaissance system. Using the basic design of the Q-2C target drone, the Model 147 evolved into various configurations. The 147A, used for early flight testing, was a standard Q-2C drone with a modified nose section which accommodated the photographic package. The fuselage was lengthened 35 inches to accommodate additional fuel. The basic 147 model was flight tested during April and May 1962. The 147C and 147D models are essentially the same as the Model 147A, with some internal changes. Lightning bug drones have been on operational status with the United States Air Force since July 1962. The photographic system consists of the Hicon Model 233 camera with image motion compensation, an oblique servo amplifier, signal integrator, window assembly, and heating blankets. Operation of the system is controlled by the programmer. From 60,000 feet altitude, a strip 300 miles long and 20 miles wide can be photographed. The 147D version, with associated equipment, provides a special capability in the area of electronic reconnaissance and surface-to-air defensive armament information. All electronic signals received by the drone are converted to video or CW level signals and transmitted to R-47 aircraft and appropriately positioned surface stations equipped to receive, assess, and record this information. If defensive weapons are fired, the radar guidance and fusing signals received by the drone are converted and transmitted. An explosion in close proximity to the drone would be within the field of view of the optical tracking equipment, and the detonation characteristics and location relative to the drone are observed and recorded by the surface optical tracking stations. Overpressures created by the explosion are measured by pressure-sensing devices on the drone and transmitted to the R-47 aircraft. Miss distance in range and azimuth from the drone can be determined from this information. Improvements to increase the navigational accuracy, operational ceiling, and range were added to the 147 model, resulting in the new Model 147B configuration. Major changes were the addition of a Doppler navigation system and a new, larger, swept-back, tapered wing. The Ryan Model 523 Doppler Navigator is a two-beam, continuous wave system. The outputs consist of a distance pulse emitted in 7-mile increments and drift angle. The distance pulse advances the programmer, which has been set to change the drone heading at specific mileage increments. The drift angle modifies the output of the heading reference to give the desired ground track. Flight testing of the Model 147B started at Holloman Air Force Base on the 25th of March 1963 under Air Force contract with headquarters AFLC MCMX as the cognizant agency. Planning for the first series of 147B test flights was based on the utilization of 3 drones. The first drone was a standard Model 147C with a Ryan Model 523 Doppler Navigator installed and was designated as the X-147C. The primary purpose of this drone was the testing of the Doppler navigation system. The second drone, a Model 147B without the Doppler system, was designated as the Model X-147B-1. This drone was used primarily for testing aerodynamic performance, flight loads, stability, and control. The third drone was a fully configured Model 147B with a Doppler navigator and photosensor installed, designated the X-147B-2. It was used for demonstrating operational performance capabilities. Each test drone was fitted with a modified Dorset FM telemetering transmitter for data acquisition. This provided 18 IRIG channels. Over 150 parameters were recorded and measured. A test nose boom capable of measuring angles of attack and side slip and pitot static pressures was installed on all 3 test drones. To accomplish the wing pressure survey, 3 scanner valves were used to record pressures from 100 ports, distributed chordwise at 5 different wing stations and 10 ports located on the upper and lower aileron surfaces of drone XB-1. captive flights were flown to check out the sway brace installation on the C-130 pylon. No undesirable vibration response occurred. Drone wing loads were also monitored to ascertain that stresses were at a safe level and that there was no indication of flutter. Results of captive flight tests showed that the drone engine compressor modulated a portion of the microwave energy, causing the Doppler tracker to lock on this signal instead of the Doppler signal, producing an erroneous ground speed solution. Modifications were made to the parabolic dish antenna, but sufficient isolation could not be obtained. A screen was installed over the engine inlet to provide additional isolation. The drag increase and thrust loss were excessive. Finally, a planar array antenna was designed, built, and installed. The array antenna proved to have sufficient isolation from the compressor blade to allow proper Doppler operation. The first free flight for the 147B was launched on the 3rd of May, 1963. Launching of the 147B proved to be normal in every respect. Because of the high altitude and increased range capability of the Model 147B drone, it was not possible to utilize chase aircraft to satisfy range safety requirements. It was therefore necessary to provide ground stations capable of tracking, control, and data acquisition. The maximum radar altitude reached during the 147B test program was 61,000 feet. The maximum range was computed to be 1,555 nautical miles. One drone, with special drag-reducing fairings installed, was flown to 62,000 feet. Stability and control proved to be excellent. Phototheodolite and tracking cameras were used to obtain recovery trajectory data and rate of descent data on both the drag and main parachutes. A new 100-foot triconical chute improved recovery, and over 80% of the flights resulted in only minor damage to the drone. On the 5th of June, the test operation was moved to the Eglin Gulf Test Range, where navigational accuracy of the system was proven. Flying according to patterns prescribed by the Air Force, accuracy over checkpoints was verified by actual photographs taken from the drone and by radar track and time position correlation. Shown here is a typical pattern flown, with checkpoints indicated. These pictures of the corresponding targets were taken during flight testing from altitudes of 55 to 60,000 feet. At the completion of 34 test flights, totaling over 60 hours, the 147B model has met or exceeded all requirements. The overall accuracy for the series of navigational demonstration flights was within 3% of the distance traveled and within 1 8/10 degree of intended heading. On 20 December, the Secretary of the Air Force approved a follow-on contract for 14 additional 147B Lightning Bug drones. Lightning Bug drones, operated by the Strategic Air Command, are on ready alert today.